The next type of fault current limiter I want to look at is involving a ferrite type of design here. This is one particular example of it, where we have a ferrite core, and there's a superconducting cylinder surrounded by the primary winding, and then, once again, in the fault condition, the superconducting tube is going to become normal, and the flux is going to couple into the iron core, thereby reducing the current in the primary. Okay, so let's look at a design that's similar to this using QuickField. Okay, let's look at the geometry file here. This is a nonlinear AC magnetics problem. And in this case, we'll look at the problem properties. Once again, we have AC magnetics 60 Hertz excitation. It's our model file. This is the air region. So this is rotational symmetry about the axis here, axis symmetry. This is the air region. Now we have a ferrite component here. This is a primary winding. As well, we have the secondary winding here. Okay. And the coupled electric circuit, we have 120 volt excitation on the primary. This is the secondary circuit. That is surrounding the ferrite core in this case. So the problem's already been solved. I want to look at the solution here. Okay. Now in this case, the superconductor, this model is a nonlinear superconductor, so we have nonlinear VH characteristics of the superconductor. And there is some penetration of the field into the superconductor. And if we look at we can animate the solution here, and you can see that during the cycle, some of the field is penetrating through the superconductor, coupling to the secondary coil. If we want to look at the current that's flowing in the primary circuit, it's something like 620 amperes at the moment. Okay, and we can compare that once again to the current that's flowing through in the unfaulted state. So let's go ahead and look at the case where this is the superconductor that's highlighted here, and I'm going to model the superconductor this time instead of a nonlinear superconductor with just a very small permeability. So this would really represent the unfaulted case, where there is no ingress field into the superconductor. And this is in this case, it's completely screening the field from the interior region. And we can look at current flowing in the primary, which is a little bit bigger here, 691. So this is reduced the current in the primary a little bit smaller than in the unfaulted case and the faulted case.